Here we go. All right. All right, I assume that the graph above is the original function. Okay? I'm not going to create, we're just going to talk. Sound good? We just talk it through? All right, here we go. Let's talk it through. You guys can write if you want. Assume that the above graph is f. Create a sign chart for f prime and for second derivative. Okay. Where do I have zeros for f prime at? Negative 1.5, 0, and 1.5. Agree? Where do I have second derivative zeros at? Here at negative 1, 1, and that's it. Why did I know those second derivatives were 0 there? They changed concavity. Those are points of inflection. Well, this is the original function, so I know for a factor because I can see the change in concavity. I can see the change in concavity. All right? So I told you I wasn't going to write. I am going to write. So what do we say? From negative infinity, let's see here, from negative infinity to, what was the first one? Negative 1.5. Okay. And then from negative 1.5 to, what was the next 0? Negative 1, because he said that's a point of inflection. From negative 1 to 0. From 0 to 1. And from 1 to 1.5, that's why I didn't write. And then from 1.5 to infinity. Okay? Let's just talk about it. Here we go. All right. Let's just talk about first derivative. Let's just talk first derivative, guys. What's the first derivative all the way from negative infinity to negative 1.5? What's the first derivative? It's decreasing, so the first derivative is negative. Here we go. From here to here. What's the first derivative? Positive. Hey, at negative 1.5, what's the first derivative? 0. At 0, what's the first derivative? From 0 to 1.5, what's the derivative? Negative. What's the derivative here at 1.5? 0. And from 1.5 to infinity, it is? Remember that one on our quiz where you went through all that? All right, let's talk second derivative. Ready? Here we go. Second derivative. What is this from here all the way to negative 1? It's concave up, therefore the second derivative is positive. Okay, everybody look at my arrow. At negative 1, what is the second derivative? 0, because it's a what? Point of inflection. From negative 1 to 1, that is concave down, so my second derivative is negative. This is a point of inflection, so at 1, the second derivative is
0.
And from 1 all the way to infinity, it is positive because that graph is concave up. Questions? All right. Now you're going to pretend, that this is the first derivative graph. Okay, ready? First derivative graph. Everybody stand up for a second. Everybody just stand up. Take a deep breath. Stand up. You guys want me to do it with you, or you want to try it on your own real quick? With me? Okay. All right, take a seat. Here we go. Is this something, I'm recording myself speaking. Is this something that you think anybody would ever want to go back and listen to? Yes. Okay, all right. So let's just talk about, if this is the first derivative, okay, that means this, and this. So what are those values? Negative 3, 0, and 3 are where the critical numbers. Why? Because the first derivative is equal to 0. This is a relative maximum. Why? Because the first derivative is positive, which means the original function is increasing. 0. First derivative is negative, therefore decreasing. Increasing, 0, decreasing. Relative maximum. Here at 0, I have neither. Because it's decreasing, 0, decreasing. Here I have a relative minimum. The derivative is negative, decreasing, 0, increasing. Okay, I'm still talking about this is the first derivative, right? Here, and here, and here are all 3 points of inflection. Because the derivative of the derivative is 0. So the second derivative is 0. Everybody agree with that? Decreasing, which means second derivative is negative. Increasing, which means second derivative is positive. So that's a point of inflection because I changed concavity. Okay, this is the first derivative graph. So therefore the derivative's derivative is 0 here. It means the second derivative is 0. Increasing, concave, up. Decreasing, concave, down. Point of inflection. Here the derivative is 0 because I'm talking about the first derivative graph. Decreasing, concave down. Increasing, concave up. Point of inflection. Ready? Now we got to think again. 3. This is the second derivative. Everybody with me? All you can do is tell concavity. There's your 3 zeros. Agree? This and this are point of inflections. Why? Because the second derivative is positive, which means concave up. 0. The second derivative is negative, concave down. Why is this not a point of inflection? Because it went from concave down and continued to be concave down. This is a point of inflection because I'm concave down. Second derivative is negative. Second derivative is positive. Point of inflection. Cameron?
So what are negative 1.5 and 1.5?
Nothing. Those are the third derivative zeros, and that doesn't tell me anything.
Or the tangent versus derivative?
No. The last thing we were doing was the second derivative graph.
Oh, this is the second derivative?
This is the second derivative. I moved to second derivative. I'm gonna hit stop recording.